hypothesis testing of a population mean using the normal distribution. Example 1. The null hypothesis, the population mean is equal to 60, and this is what we're actually testing. The alternative hypothesis, the mean is less than 60, so the mean has decreased. We're using a 5% significance level, and this will be a one-tailed test, and this is using the probabilities method, which is the easiest method out of all the available methods. So if you have a choice, always go with this one, it's easier. Now the underlying population is normally distributed, and we have population mean of 60. This value, and this value are always the same, and this is a variance. So we take a random sample from this population, and 16 values were chosen randomly, and the mean, the sample mean of those 16 values was found to be 59.1. This is our test statistic, the distribution of the sample mean. So this is the same as this value and these. This fraction comes from sigma squared over n. Now sigma squared, there the variance was 9, so that's where that 9 comes from in the numerator. Divide by n, divide by 16. So we'll do a normal distribution sketch for the sample mean for this distribution. We put 60 in the center, that's the mean. We take our test statistic 59.1, we mark that on the sketch, so 59.1 will be on the left hand side here. And now we always calculate the probability from the line that we've drawn going outwards. So we need the probability of this region. So from the calculator, the probability in this region is 0.115. Now we need to compare that to the probability here, which is 0.05. So you can either compare the probabilities, or you can compare them as percentages. So if the probability that you've just calculated is bigger than your significance level probability, then you accept H0. So there's insufficient evidence for H1, insufficient evidence to say that the population mean is less than 60 and that it's decreased. We can see from the test value 59.1 it's less than the mean of 60. So there is some indication that the mean has decreased, but the evidence is not sufficient, it's insufficient. We need a significant amount of evidence, which we don't have here, hence the acceptance of H0. Part B, so we're doing the same hypothesis test now, but we're going to use what we call the critical regions method. So it starts off the same population distribution, random sample, distribution of the sample mean, no changes here. Mean is 60. CV, this is the critical value, and this region here, the shaded region here, is called the critical region. If our test value, which is 59.1, falls in this region, we will reject H0. If our test value falls anywhere on this side, we will accept H0. CR, the critical region, hence the critical regions method. The probability that goes into the critical region is always your significance level for a one-tailed test. So 5% in here, or 0.05, and we're going to use the inverse normal distribution, and we can calculate the value here for our critical value. The critical value is where the critical region starts from. So doing the calculations, we have 58.8, that's our critical value. So any value that's less than or equal to 58.8, so in this direction, falls into the critical region and leads to a rejection of H0. Our test value is 59.1, and 59.1 is on this side, it's in the acceptance region, so our conclusion will be to accept H0 and say that there's insufficient evidence to say that the population mean has decreased.